On today's video, we look at the Kenwood TR2500, a fantastically rugged radio introduced by Kenwood in 1983. On this video, we tune the radio up on transmit and receive, and we revamp the old battery, bringing it right up to date with some fresh lipo. The radio is only a single band and covers the 2 meter FM band with an adjustable value of 0.3 watts on low and up to 2.5 watts on high. It covers 144 to 147995 MHz and has 10 programmable memory slots. It also has DTMF tones, 1750 Hz tones. It covers both positive and negative repeater shifting, and this version comes with an adjustable CT-CSS encoder, which we will adjust later using the SDR and the K-Tone app for CT-CSS detection. At the time, they also did sell the TR2500 that covered the 70cm band, and that looked identical otherwise than the badge at the top of the radio. Now, as you'd imagine on this one, the battery itself has long since conked out and was a fairly weighty nickel metal hydride version in this radio, and I think I measured about 0.3 of a volt off the back of the battery. I mean, look at that for a belt clip. That's incredibly sturdy, but this is how they built them back then in the day. I think you could run your car over this radio and it would still be fine. I was really pleased to see that this radio also come with the original antenna as well, something you very rarely see actually on radios of this vintage, and it's got the Trio Kenwood badge printed on the side of it in a nice orange colour there. So that was nice that that was included. So we got the usual little bit of crackle on the knobs as you turn it on, but I could see straight away that one of the memory channels was active and the backlight thankfully did work. And so I plugged in the FT70D and we had a little play around, just transmitted to and from either radio. 1 2 test, 1 2 test, G7LNK test. And it seemed to be there or thereabouts, but I thought I would hook it up to the equipment and give it a proper test. I haven't actually got an FM signal generator that will run up at this frequency at the moment, but we can certainly test the transmit side. Now there you can see the lithium battery, that's a CR2032 soldered in, and that holds all the memories when you take the main battery off the radio. It was fairly clean inside the radio. I was very pleased to see that although it had a tough life externally, internally it had not, I don't think, had the covers off. It certainly didn't look like anybody had been in here since manufacture. And the advantage of a radio bit of this age is that the technical information is out there. So I got the radio on frequency, and this is the FT70D on transmit, and then this is this radio. So I could see straight away it was about 180 Hz off, so slightly out of spec. And the test and equipment here and the is not obviously it's not lab accurate, but it's certainly, that was certainly out. So anyway, I decided that we would pull that in. So we warmed up the counter and I found the VCO there, and we just, using the SDR because it was quicker to do it and eyeball it like this, we brought it down there or thereabouts to the correct position. This is where the SDR comes in very useful, because the gate time on these cheap frequency counters isn't the best. So we tweaked the power up as well, and we got managed to get a little bit of activity out of the radio. So it seemed to tune up okay, and this is all I could do for receive, was to listen to a local repeater while 26 miles away. And so I deemed that that was the best I could do to check the receiver on this radio at this point in time. So as I mentioned, the battery itself was completely flat, and obviously you cannot get new cells, so the only way to rejuvenate this is to put new cells within this casing. Now I wasn't quite sure what screws needed removing to open this battery, but actually none of them need removing. I've since found out those are the terminals for the external charger that you would use to charge or run this radio, and that unusually is a little switch that disconnects the batteries inside when it's connected to the external standalone power unit, which powers the radio rather than charges the battery. Now I opened up the battery case at the top here, and it was still pinned in at the bottom, so it's very important if you ever do open cases like this, please use plastic tools, don't put sharp metal objects in there, and always pry them open, don't lever them open, because you'll snap the retaining tabs. You'll see there at the bottom, had I have levered that open, it would have snapped those tabs off. So just be very careful when you're opening batteries not to do that. And you'll see inside that these are large format nickel metal hydride cells. They're somewhere in between a AAA and a Type C. And they also have a temperature thermistor cutout, which is shown on the wiring diagram, which we'll see in a second, to obviously monitor the temperature of the batteries when they're charging. And there you'll see from the this has already had a replacement set of cells in, as you can see from the bit of tape there joining them together. So I decided we would get more capacity by using two of these little lithium polymer batteries in series. These batteries have a built-in battery protection circuit as well, so they're safe to use in this application, and they fitted this case absolutely perfectly. And I keep the little mini JST connectors as well, so it's very easy to make up a small harness to fit inside these battery cases. So we just seriesed a pair of these little batteries up together, and then looking at the circuit, I could see we needed to remove this resistor in order to charge it externally. This is a resistor that would have been conventionally used to limit the charge current when it was running on nickel metal hydride. So, and we don't need to do that with constant current charging, of course, because we're going to charge it with a very old lithium ion battery charger I've had off an old bike somewhere. So we made the swap over, and it was quite incredible, the difference in weight between the old battery pack and the new battery pack. Quite unbelievable. So I dug out this old lithium ion charger. I was literally going to throw this away fairly recently, so that was lucky. I dug this out. The only thing I had to do was to swap the lead over because the polarity was different. I decided to leave the radio as standard and swap that over. The battery was only ever so slightly low, slightly down, should be 8.4. So we stuck it on the charger and we brought it up to 4.1 roughly per cell, 4.15-ish. So that was near, nicely under 4.2 volts for each cell. And you'll see there in terms of weight, 131 grams versus this tiny little fella, which is I think it was 17, so 34 grams for the two. So you can see the considerable weight difference between the two battery packs now, considerably lighter. So yes, that was a very good modification to carry out. And I hope that some of you, if you do need to do this, you probably will go this way. Those little lithium battery packs are available online. You can get them pretty much anywhere in differing sizes, so you just have to check the size. And there we go. I sprayed some switch cleaner in the knobs and all the switches when I had this apart, and so I was pretty confident all those switches would be okay. And I went through all of the functions to test that they all worked. And then I like to do the field test, the field strength test as well, just to check to see if the antenna is working okay. And then I thought we'd do a quick test room to room with a new radio versus the old radio, as we did in the last Kenwood test. And then you can see the weight difference between the two radios. Still quite a difference. So let's listen to them room to room and see how they sound.
This is G7LNK testing the ASU FT70D in analog mode. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1 to the Kenwood 2500. The quick brown fox jumped over the lazy dog. This is G7LNK testing the Kenwood TR2500 into the ASU FT70D. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. The quick brown fox jumped over the lazy dog.
Right, so I wasn't sure what CTCSS tones were enabled, and I wanted to run this on my local repeater, so I use this superb little plugin called KG Tone, which you can use on SDR Sharp or SDR Play, and there's videos which I'll link to which show you how to use this. And it detected the programmed CTCSS tones as 107, and I needed to get it onto my local repeater, and that's the adjustment knob for it there. So I checked up on GB3VA to pick the tone up, and we adjusted up that until KG Tone picked up the 118.8, which was the correct CTCSS tone. So if you tune into the next video, you'll see how we get on with this radio when we try and use it on the repeater. We'll also take it out to site with Mick and do a couple of tests in the two usual locations, and we'll have a little play around and see how we get on with this lovely looking, I hope you probably agree with me, old radio. So I hope you've enjoyed this and you found it useful, and please don't forget to like and subscribe. It always really helps me when you do that, and it gives me the impetus to keep making these videos, and hopefully others will find them useful and be able to bring their old radios back up to scratch with a little bit of help from myself. Okay, if you have been, have a great weekend. Catch you on the next one, 73.